Okay, the last part of this video, we're just going to talk about application questions for inverses. So what we have is this function on the grid, okay, and you can see it's a combination of a line and then a parabola and then another line. And there's no arrows anywhere, so that means this function actually stops right here and it stops here. Okay, so we want to state the domain and range for this blue function, which we're calling f at x. For the domain, we take a look at the x values. So you can see the farthest it goes over on the left-hand side, x-wise, is -3. And the farthest it goes over on the right side is +3. So when we write our domain, we want to make sure we say x is between, so between -3 and +3. So it's similar to when we did the domain and range of a circle. For the range, again, same thing. You look at your graph and you see the lowest y value on the graph is -5. Okay, and the highest y value is +2. So when we write our range, we want to say y is between -5 and +2. Okay, so there's our domain and range for the blue function on the grid, f at x. The next thing we want to do is sketch the inverse of f at x. So we want to sketch the inverse of the blue function. The best way to do that is to choose some key points, and then we reflect those points across the xy line. And the way we do that is we switch their x and y values. So for this function, okay, we have a couple key points. We have the end point here. Okay, so I'm just going to write them out as we look at them. So for that point, our x is -3 and our y is -5. Okay, the next key point is here, -2 and 2. If you look, this would be our next key point, the bottom, the vertex of this part of a parabola. So 0, -2. And then up here at 2, 2. And the last key point would be at 3, -5. Okay, so you want to choose points that makes it easy to reflect, right? So there's no point of choosing this point here because it's not a very clear point to begin with, so it's not going to be helpful for us to try to reflect it. Okay, so you want to choose clear points that help define the shape of the graph. So to sketch the inverse, what we want to do is we want to switch all of our x's and y's. So for my inverse graph, okay, instead of having -5, it's going to be -5, -3. Okay, I'm switching my x and y values. So this one is +2. Oh no, so we're switching, so 2 and -2. Okay, -2 and 0, 2 and 2, and the last one would be -5 and 3. So when I graph my inverse, now I should be able to graph these 5 points and then fill in the rest of the function based on the shape from the original function. So -5, -3 is my first point. 2, -2. Okay, -2 and 0 is right here. 2, 2 stayed where it is. And -5, +3. It's right here. So you can see the 5 key points make the basic shape of the graph as long as you know what the original one looked like. So I have a line connecting these 2 points, okay, and then I have my parabola, and then I have a line connecting my last 2 points here. Okay, so it looks a bit messy on the graph. That's why I chose to do it in a different color. But you can still see that the entire graph has been reflected on the x or y axis. Okay, so the last thing we want to do is state the domain and range of our new function, or not our function, our new graph, our inverse. Okay, I shouldn't say function because you can see right away from the graph it's not a function, right? It fails the vertical line test at every point. So when we state the domain and range, all we have to do is switch our domain and range from the original function. Okay, so you don't have to look at the graph and rewrite it. You can just switch the original domain and range, and that will match your inverse. So in this case, our range is going to be between -3 and 3, and our domain is going to be between -5 and 2. Okay, so I'm going to write that here. So for our new relation, our inverse, our domain is between -5 and 2. And if you look at the graph, okay, you can see that it goes from -5 to 2. Okay, but all I'm doing is copying the range from the original one, and now it's our domain. And the range was the original function's domain, so the range is -3 and 3. Okay, so the domain is still x, the range is still y, but the restrictions have switched from the original one. And if you double check with the graph, our range goes from -3 up to +3.